Good morning. We are starting Unit 3 of SEM 2. So, SEM 2 exams also, and maybe in the nearby month. So, be focused on the topics what we explain in our classes. So, only read these questions for high and better score. So, this is my suggestion. So, coming to the Unit 3 syllabus is quantum theory of radiation. So everyone is aware of what is radiation. Okay, radiation we seen in lower classes. Okay, in the lower classes also we saw about the radiation and types of radiation. So in this unit we particularly focus on the quantum theory of radiation, right? So in this quantum theory of radiation, few scientists were developed these quantum theory of radiations. Okay, first of all, quanta is nothing but a packet of energy. Quanta is nothing but a packet of energy. So firstly, these mainly the radiation or the quantum theory of radiation is full-fledgedly given by the famous scientist known as Max Planck. So Max Planck given the full-fledged formula for the quantum theory of radiation. Okay, so before Max Planck, many scientists were worked on these quantum theory of radiation, like Rayleigh and Jeans and Wiens. Okay, so a few scientists were worked on these quantum theory of radiation to develop these quantum theory or to explain the quantum theory of particular radiation. So but the Max Planck given a full-fledged formula or full-fledged theory, quantum theory of particular radiation. Okay, so what is a quantum theory according to the Max Planck means? If let us take a black body radiator. If you took a black body radiator, it contains a simple harmonic motions. Okay, it contains a simple harmonic motions. Now the black body contains the simple harmonic motions. So according to quantum theory of Max Planck, the energy radiating will changes takes place discontinuously and discretely as an integral multiple of a small unit of energy called a quantum. I said already quantum is a packet of energy. Okay, so the Planck's given that the radiating energy will be changes according to its discontinuous nature, and discretely we can take as a count of that small unit of energy called a quantum. Okay, based on this quantum theory, Max Planck evolved a greatest expression that D is equal to E lambda D lambda, the energy density is equal to 8 pi hc by lambda 5, okay, lambda power 5 into 1 by exponential minus 1 into d lambda. So here h is the Max Planck's constant. We say h is the Planck's constant. So the Planck's constant value or the Planck's law is valid for all the type of wavelengths, whether the wavelength may be a short, whether the wavelength may be a long, but it is valid for all the wavelengths. Like if you compare with the other laws like religion's law, if the religion's law is only applied for the longer wavelengths, it is failed for the shorter wavelengths. And Wien's law is only valid for the shorter wavelengths, it failed on a longer wavelength. Okay, so but the Planck's law is applicable to all the laws, okay, all the wavelengths of any kind of wavelength, whether it may be a short range, whether it may be a longer range. Okay, this is a quantum theory which is proposed by the Max Planck. Okay, remember that the Max Planck proposed the quantum theory of radiation. Planck's law is only valid for all the wavelengths, but when compared to the other laws like Wien's, it only applicable to shorter, and religion's law, it is only applicable to longer wavelengths. But the Planck's law is main advantage is that it is applicable to all kind of wavelengths. Okay, now coming to the point that what is the black body and its radiation. First of all, what is the black body and what kind of radiation it evolves means? So a perfect black body is nothing but which completely absorbs all the radiations of incident wavelength. Okay, so a complete perfect black body is nothing but which absorbs all the radiations of all the wavelengths incident on it. All the radiations of all the wavelengths incident on it. So it only it absorbs the radiations, neither it transmits, neither it reflects any kind of radiations. Okay, remember that a black body is a perfect black body is nothing but which absorbs all the kind of radiating particles of all the wavelengths incident on it, but it neither transmits or nor reflects any radiation. Okay, it just appears black, which whatever may be the color of incident, whatever color we incident, okay, but it appears black only. But according to the Kirchhoff's law, okay, according to the Kirchhoff's law, what the black body means, a perfect black body is nothing but it should not only absorb the radiation of all the wavelengths, but it should emit the radiation. Then only it should be said that a black body. According to whom? According to the Kirchhoffs. So according to the Kirchhoffs, a black body is nothing but a black body is a good observer as well as a good radiator. So when it emits the radiation means when it is heated to a suitable high temperature, then it emits the radiation of all the wavelengths like a continuous spectrumly. It emits the radiation at higher temperature. So the radiation emitted by a black body in a maximal possible wavelengths, and hence that kind of radiations are known as full radiations or the total radiations of particular black body. Okay, so the wavelength of a emitted radiation is completely depend on its temperature. Okay, the radiations which are going to emitted by a black body, which is completely dependent upon the its temperature, and it does not depend upon the material made, what kind of material we used for the black body. Okay, so generally there is no perfectly black body is there in character, but the nearest approach black body is we consider as a lamp black or platinum black. Okay, we use a black body as a lamp black or a platinum black. Okay, these are capable of absorbing the visible and a part of near infrared but far infrared when it is going to be reflected. Okay, the lamp platinum black is capable of observing the visible part and a part nearer and infrared, but far infrared are reflected. So perfect black body is just an ideal concept. Okay, perfect black body is just is in our assumptions only. Okay, so this is a complete view of black body. Now Ferri's black body. What is a Ferri black body and what is the difference between the black body and the Ferri's black body is nothing but, so this black body explained by the Ferri scientist. Okay, so it consists of a double walled conducting sphere. Okay, it consists of a double walled conducting sphere. Look at the diagram. So the interspace between the walls, the space is given between the two walls. Okay, the space is given between the two walls, so that it is in the form of evacuated to prevent the loss of heat by convection and conduction. So the space is given due to to prevent or to minimize the loss of heat produced by the conduction or convection and convection. So let us consider a small hole. Okay, let us consider a small hole O. Okay, and a conical projection P outside the outside the hole O. We are considering a hole O, and outside from the hole we are making the projection P. Okay, it is a lamp blacked inside and the nickel polished outside. So the inside sphere is completely polished by the lamp black, and the outside sphere is completely filled with the or polished with the nickel. Okay, when the radiation is incident on the hole, when this is a construction, and when the radiation is incident on this hole from the O, it passes inside to the, okay, it passes inside to the spheres enclosure. So then the radiation suffers multiple reflections inside the sphere. Radiations undergoes into multiple reflections inside the sphere only. Okay, so there is hardly any possibility of the radiation to get out except by radiation reflection from the surface opposite to the hole. So there is only a single chance of emitting radiation is only from the entryway, okay, that is from the hole only. So no other way is there for the reflecting outside the body. Only the hole O is there for the exit or emit of the radiations. Okay, so this is eliminated by the projection P. In this way, any radiation that enters the body does not escape and only it gets absorbed. This is a kind of black body given by Ferris. So therefore, the body appears as perfectly black, hence the whole behaves very closely like a black body. Hence from the whole, if you see, it looks like a complete a black body due to the multiple reflections inside the sphere. So if the enclosure is heated to a definite temperature, it is filled with the black radiation having all the possible wavelengths. So this is a complete view of a Ferris black body.